Welcome GeoTrig, this is section 7.2, similar polygons. The essential question is, how can you use ratio to decide if two polygons are similar? Let's begin. So, similar figures, this is a new chapter this week. Similar figures is the same shape but not necessarily the same size. And we use this little tilde, not an equal sign, not a congruent sign, when we want to equate two things that are similar. So for example, the Earth and globe, they're similar figures because they're both that spherical shape, but they're not the same size. One of them's a little bit bigger. The Earth is. Similar polygons are where corresponding angles are congruent, but corresponding sides are proportional. So for example, these two polygons, we got AG and BH, CI, and DJ are congruent, but our sides are not going to be the same. They actually have the same portion or same ratio. So you can say A over B, AB over GH equals BC over HI equals CD over IJ. So they're all going to be the same proportion. They're going to be proportional, but they're not going to be equal. We have this idea called a scale factor. So scale factor is the ratio of corresponding linear measurements of similar figures. What does that mean in English? It's basically a fraction that shows how much we're scaling up and down. So if we have two similar triangles here, you can figure out the scaling factor. I'm saying they're similar. You just have to create a ratio of two of the corresponding parts. So B and A is corresponding with YZ, so you can do, or BC corresponds with ZY, so you can do BC over YZ, which is 20 over 8, reduces to 5 over 2. So in this case, we call it the scale factor of these two triangles is ABC to 2XYZ is 5 over 2 or 5:2. Either notation you might see. And note the way to say this, ABC to XYZ, that means whatever ABC is on top and XYZ is on bottom. That's important because otherwise if you said XYZ first, it'd be 2/5. So that'd be a different scaling factor. You had other vocab in the book here, scale drawing. I think it's stuff you've done before. You know what this means. All lengths are proportional to the corresponding actual lengths. And so it's, you see a real map. And the scale drawing is, this is not the actual size of our school, right? It's a little bit bigger than this because this is a school for ants. And we have this scale on the bottom of the drawing that actually shows us what our proportions are. So it looks like about 1 centimeter, about 50 feet in this drawing, if you are viewing it on a computer with the right size monitor. But anyways, let's do some examples. Pause the video. Okay, what are pairs of congruent angles? So if I said triangle MNP is similar to SRT, pairs of congruent angles are just matching up the letters. So angle M is going to be congruent with angle S, angle N is congruent with angle R, and angle P is congruent with angle T. Alright, next step, what is the extended proportion for the ratios of corresponding sides? That means just do the big fraction thing. So we'd say side, let's start with MN. MN over SR equals the proportions NP over RT, which is going to equal the proportions of PM over TS. That's what that is. Alright, pause the video. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So J, K, L, M, and T, U, V, W. So you have to make sure that the corresponding angles are congruent. So J is T, K is U, L is V, and M and W. Okay, so the angles check out. Angles check out. Now we got to see if the sides are proportional. So to do that right, we'd have to say JM over TW. So I'm going to go 6 over 6. So I'll call this 1 and 1. Has to equal this side. I'll call this 2 over 2. So 12 over 6 has to be equivalent to this side. So it will be 24 over 16 has to equal this side. Let's call this side 4. 24 over 14. Well, these ratios, if we simplify these, this is 1, this is 2, this is, oh boy, that's going to be 3/2, and this one's going to be divided by 2, 12/7. No, these would have to have the same ratio. We say, are these polygons similar? Nope. If they are, write a similar. No, they're not similar at all because they all have different proportions. Alright, try the last one. Okay, so it says they are similar, so what's the value of x? So we've got to do some math here. So the first thing I can say is I know this side to this side over this side, it equals this whole side over this whole side. So let's create an equation. So I'm going to say 9 over 6 equals the big one's top 5 over the little one's top y. So we can solve for y here. Well, one thing you can do, you can flip diagonals when you have two fractions equal to each other. So I'm going to rewrite that as y over 6 equals 5 over 9. Now next thing I'm going to multiply both sides by 6. And so you're going to get y equals 56 over 9. So these actually reduce. You can reduce that by 3. So 3 and 2. So that's going to be 10/3. So y equals 10/3. That doesn't help me yet though, because I got to get x. So actually, was that even important? Maybe not. Maybe it wasn't important at all. No, it wasn't. That was a waste of my time. Okay, let's do x. So big long side 7.5 over x equals, let's do this big long side, 9 over 6. We could have just done it like this without messing with the y. Alright, so again, I can flip the diagonals here, so it's going to be 7.5 over 9 equals x over 6. I will multiply both sides by 6. Once you do that, this is going to cancel 3 to 2. And so you're going to cancel here. My x is going to get 2 times 7.5 is going to be 15 over 3. And hey, that reduces to x equals 5. There we go. I solved for y just for fun. That's it.